Okay. So
Hello.
we were discussing about redox reactions, and see, these are like pretty easy ones. You could go through them. Just they haven't even given you the whole equation. Okay, just the see. Tell me, is it oxidation reaction or reduction reaction? Mg2 plus 2E minus.
Um, Reduction.
Reduction, because there is a gain of electron. Okay, and this would be
Uh, that's reduction.
no oxidation. That is why I said.
No, oxidation. There you
Yes,
go.
that is why I said key take the electron to the left side. Okay, take the electron to the left side. Okay, all right. Okay, so now for consider the half equation Ag plus. Okay, so you could read them up. I if you find any difficulties in understanding, please let me know. Okay, but these are the things you have to read them up. Okay, all right, for your better understanding. Okay, let's see. Okay, this is good. Like highlight the key information in the question. Say, for instance, when two ions react with magnesium metal, tin metal and magnesium ions form. Okay, so if I give you the equation like this, so the equation will be something like this. Okay, so SnCl2 plus Mg, then we get MgCl2 plus Sn. Okay. So that will be the equation or reaction that will be given to you. Okay. Now they have said identify one reactant and the product it forms. Okay. But I would suggest that don't go in this way. Identify the oxidation numbers. +2, -1, 0. +2, -1, and 0. Like this. Then identify where is the change in oxidation number. Obviously, there is no change in chlorine's oxidation number. Okay. But there is change in tin's oxidation number. And what is the change? It has gained electrons, and that means it's a reduction. Okay, it's a reduction. In case of magnesium, however, it's a oxidation. Okay, and then you can easily write down the equations. But obviously, read out the whole book, and if you think that this helps you more, no worries. Okay, but I think like writing down the oxidation numbers are way too much easier in my view. Yeah. All right, now tell me what will be the oxidation reactions and reduction reactions. Okay, tell me by forming them.
Oxidation would be no reduction would be the Sn tin,
Yes, Sn.
and oxidation would be for the magnesium.
I mean, this is the thing I wrote with arrows. No, I'm not wanting that. Like the whole reaction,
Oh, what?
the whole half reactions. Okay, what will be the
Hmm.
oxidation half reaction? What will be the reduction half reaction? How many electrons would be donated or accepted? What will be the ions? What will be the product that will be formed? Okay, the whole thing.
Oh, okay. See, numbers. Sn
Yes,
plus two E minus
Sn2
results in
plus 2E minus results in.
Sn
Okay, good.
half reduction,
This is half reduction, correct. Half red. Then
then Mg minus 2E negative
mm-hmm,
results in Mg2 plus
Mg2 plus.
half oxidation.
Good. That is what I wanted. Okay, half
Okay,
oxidation.
cool.
If you are able to understand this bit, I am telling you, this will account for like a huge amount of marks in your examination. Okay. All right. So now, what I was saying is, yes, I was about to ask one question to you. What was that question? Yes. Okay. So see. always we write E minus, E minus. What is the purpose behind writing E minus? Do you know that?
Electron is a negative charge.
Okay, electron is a negative charge, but whenever you will write protons, do you write proton plus or neutron zero?
No,
I mean, not.
no.
So the reason behind it is that the chemists found out that there are particles found which are E plus as well. Okay, these are
What?
termed as negatron. Negatron. I don't know the spelling. Maybe something like this. Okay, so that is these particles are called negatron. That is why whenever we write electrons, we um, write it with a negative charge. Okay. Okay, let us check as well. The name actually should be correct. Positron, or was it positron? Or was it positron? Actually, it could be positron. One second. Positron. See, positron symbol is E plus. Okay, positron, not negatron. It's positron. Okay. All right. I mean, you don't have to understand it now. Just know it. Okay, you will read it further later. Okay. All right. So now let's, okay, so these are the working procedures. You can take a look at them. And sodium, then sodium plus. Okay, I mean, these are like very easy ones. They haven't even given you the whole equation. Okay. Okay. Identifying oxidizing agents and reducing agents. In a redox reaction, electrons are transferred. In a redox reaction, the substance that is reduced is the oxidizing agent, and it called. Okay, I think if you read these things, this might get difficult. Just follow my class note. What did I say? That oxidizing agents are related to reduction, and reducing agents
Reduction.
are related to oxidation. Okay.
Oxidation.
Right. Now we know that reduction is gain. Okay, that means oxidizing agents will also gain electrons. Okay, all right. So that is how you can like remember it. Okay. Otherwise, if you like go through these, I mean, I think you might get confused. Okay. All right. Now next up, let's see. Okay, so now see reducing agent. Now is this the important thing? Okay. So now obviously we know that reducing agents are keen to like donate electrons. Okay. Reducing agents are keen to donate electrons. Like say metals, say sodium. Okay, sodium is a reducing agent. It likes to reduce or give away electrons. Okay. Now the given electron, who will take it? It will be
Me. I will
taken
take it.
by oxidizing agents. Okay. It
Okay.
It can be oxidizing agent. Say for instance, chlorine. Chlorine will take this electron to get chloride ion, and all together they will form Na plus plus Cl minus, altogether sodium chloride. Okay, so this is how an equation forms, or maybe redox reactions form. Okay, all right. So see, reducing agent loses electrons, reduces oxidizing agent. In my view, this is a very like very difficult to understand term, like reducing the oxidizing agent. No, I would prefer you write it in your own words that reducing agents lose electron or give away electron, and oxidizing agents accept those electrons. Okay, that is enough. All right, but writing down reduces the oxidizing agent, you can remember it, but it's I mean, if the question doesn't ask you, you don't have to write it, or just don't mess it up while writing it. Okay. All right. Okay. Yeah, that's about it. That's about it, I guess here. And reducing agents undergoes oxidation. This is important. Which undergoes oxidation? See, reducing agent undergoes oxidation. This is very important. and oxidizing agent undergoes reduction. So this chart is important actually to see it, but without the number 2 point. I will obviously see the number 2 point. I can't say that you don't read it, but just don't get confused with it. Okay.
Got it.
All right. Okay, so it's the end of the chapter here. They didn't even show that much difficult equations. Okay, let's see. Okay, you were asked to do these things, but you didn't do, I guess. Okay, just give some time on them. Okay, 3 to 4 minutes. This homework will take 3 to 4 minutes. Okay. All right. So oxidation reduction is a simultaneous process. By that, what they mean is oxidation can't take place alone and reduction can't take place alone. They have to work together. Okay, or they have to perform the reaction together. Understand?
Yes.
And oxidation reduction reactions are of 4 types. Okay. Firstly, actually you could find other than those as well, I guess, but they have like distinguished these four at your level. First of all, addition reaction, decomposition reaction, substitution or displacement reaction, combustion reaction. I don't know if they will be included in your syllabus or not, but let's just go through them. Now, what is a addition reaction? Addition reaction means some part will get included to a particular compound already been made. Okay, see here, ferrous chloride. Okay, ferrous chloride was already made. Okay, and then we are making ferric chloride. And now, how are we making ferric chloride? With the addition of chlorine gas. Understand my point? With the addition of
Yes.
chlorine gas, we are getting ferric chloride. That is why we are terming it addition reaction. Okay, be real quick and let me know what will be the oxidation, half oxidation reaction and half reduction reaction in this reaction. Okay, I'm giving you,
Okay.
take your time, but you have to practice it. I won't say anything to you. Do it in the notebook.
Wait,
Okay.
how will I practice? Wait, what am I practicing?
What are you practicing? Okay, firstly write down the equation, the whole equation, and then figure out what are the oxidation numbers, what are the oxidation numbers of each and every element here, and then write down the redox reaction, I mean the half reduction reaction and half oxidation reaction. Okay, like we did previously. You can check your notebook for other seeing other equations as well, no problem.
Quick question.
You can't say good question.
Um,
First, identify the
no,
oxidation.
no, no. Oh, no. Quick question is quick
Oh, okay, good
question.
question. Okay, all right. Yes, go ahead.
Is that chemical equation balanced?
Mm, no, you have to balance it. You have to balance it.
I don't wanna balance it.
Just write a two
Okay.
in the right side. Just a two on the one
Yeah,
side.
I know. It's funny if I just complain.
If your question setter gives only one-sided arrow sign, okay, then you have to check if whether the equation is balanced or not. Okay, but if they give you a equation sign like an equal sign, then you could be sure that okay, this equation is balanced. Okay.
Wait, what am I looking for again?
Sorry.
What am I looking for again?
Write down the half reduction reaction and half oxidation reaction.
Oh, okay. Okay, I'm lost. Fe gains, no, loses 2. Is that right? Okay, I'm lost.
Okay. I hope you could write something because you have to keep on practicing. Okay, I will give you some homeworks today as well. All right, because otherwise we'll keep on forgetting. Okay, let's go through the process. Fe is +2 here and then -1 here. Chlorine is 0 here, and Fe will show a different valency or oxidation number here, which is +3. Chlorine is -1. Okay. Now let's start from the left side. So Fe2 plus will balance later on. Okay, balance later on. First of all, let's just see how the oxidation reduction procedure goes. So iron loses 1 electron or gives away 1 electron to become Fe3 plus. Okay. So this is our which process? Tell me. Tell me.
That's a reduction.
That's a reaction. Are you sure?
Oxidation. Oxidation. Sorry.
All right. Now, next up, okay. Let me write one thing down. See, this is the portion where you are seeing oxidation. Okay. All right. Now tell me, which would be the reduction part here? Which would be the reduction part?
That would be the chlorine.
Which chlorine? There are 2 chlorines.
Oh yeah, true. Sorry. The chlorine with 0
Yes.
gas.
Then it goes into here. Okay. That's a very important thing. So that means chlorine will receive 1 electron and become chlorine minus. So that is our half reduction reaction. Okay. All right. Now we have to balance it. We had 2 Fe2 pluses, so that means 2 electrons and then 2 Fe3 pluses at the right side as well. And in case of chlorine, we had 2 chlorines and then we will get 2 chloride ions as well. Yeah. All right. Now you might ask why there are 6 chlorines on the right side. Okay, yes, see, there are 6 chlorines, but in case of 2 chlorines only, we can see the reduction reaction. Okay, understand my point? All right.
Yeah.
Yes. All right. There is not like acceptance of 6 electrons, rather there is acceptance of 2 electrons. All right, because see, there were 2 chlorines with a charge of 0, and then we get 2 chlorine with a charge of -1. But the other 4 chlorines which had a charge of -1, they also had a charge of -1. So is there any reduction occurring?
No.
Okay, and let me clarify it again. So there are 4 chlorines with charge -1 charge. Okay, then 4 chlorines
Yes.
with -1 again. There is no reduction occurring here, right? Is
Oh,
it correct? But 2
yes.
chlorine with 0 and then 2 chlorine with -1. So there is a reduction occurring here. Okay.
Okay.
So you have to practice more and more to master this thing. So let me give you some equations now. All right. Okay, I'll just take a quick note of this.
Got it.
Already done? Okay, good. Okay, write down this one. N this is pretty easy. Actually, do everything. N2 plus 3H2 to NH3. N2 plus 3H2 to NH3. N2 plus 3H2 to NH3. Remember this equation very well. We will work with this when we study last of the Lewis
Ammonium.
principle as well. Okay, sorry.
Yes. Apparently ammonium was made by Nazi.
Yes, yes, yes.
Sorry. Anyways, yes. Okay. Sorry. Fun fact.
Yes. All right. Okay, now. So now PCl5, then PCl3 plus Cl2. Okay. Now what you will do is from the left side PCl5, phosphorus is +5 and chlorine is -1, and then look into the right side, phosphorus will be +3. Okay, then chlorine will be -1 here, but chlorine will be 0 here. Okay, so work like this, -1 to 0 and 5 to +3. Okay, I've given you hint as well. All right.
Yes.
So write down this one and then this one as well. I am giving you very easy ones. Like, so these are not difficult ones. You will not get difficult ones either. Okay. And 2H2O and 2H2 plus O2.
Got it.
Okay. Then zinc plus H2SO4, zinc sulfate plus H2. Done?
Yep.
Okay, I think any of the combustion. Okay, just write down this one. This one should do. Methane plus 2 oxygen, carbon dioxide plus 2 H2O.
Done.
Okay, good. All right. So when can we meet next? Are you free on Friday?
I am free on Fridays. Surprisingly.
Friday, 7th of October. At what time?
Well, I am finishing school at 1, coming home at 2:30. 3, if that's okay with you, or
Yes, it's okay.
3/11.
Okay, good. Okay. Yes, and so we will be done before the Zumba prayer, so that is also good. Okay, 7th October. That is Friday,
Yes.
11 a.m. or 3 p.m. Okay. You then, inshallah. Okay. Allah Hafiz.
Inshallah. Allah Hafiz.